Data types in C. C data types are broadly classified as primary data types and secondary data types. Under the heading primary data types, we have character, integer, float, and double data type. Whereas in secondary data type, we have arrays, pointers, structure, union, and enumeration. Let us talk about the primary data types. Integer data type. The allowable range for integer is minus 32,768 to plus 32,767, 16-bit. For a 32-bit computer, of course, the range would be much larger. In integer, 2 bytes, the 16-bit is used to store the sign of the integer. 1 if the number is negative, 0 if the number is positive. In C, integers are classified as long integers and short integers. They are represented as decimal, octal, and hexadecimal. It requires 1 word of memory for storage and internally stored as binary. The high order bit, as I mentioned, represents the sign. For example, to declare a variable of integer data type, you will specify int space the variable name and terminated by a semicolon, that is integer I semicolon. If you want to define multiple variables, you can do it by separating the variables with a comma. The second example shows declaration as well as initialization of a variable. Integer p is equal to 320 and r is equal to minus 100. As mentioned, C accepts integers as decimal, octal, or hexadecimal. There are a few qualifiers that can be applied to these basic types, that is short and long, which will vary the size of the variable, signed and unsigned, that varies the range. Integer, the representation and its decimal equivalent. For example, the integer 6291 is a pure decimal representation and its decimal equivalent is the same. Similarly, a negative number minus 592, in decimal its equivalent is also the same. Whereas any number that is prefixed with a 0 is an octal representation. Say for example 025 is treated as an octal number and its decimal equivalent is 21. Any number that is prefixed with a 0 followed by a x is a hexadecimal representation. For example, 0xd3 is a hexadecimal number and its decimal equivalent is 195. To specify any number to be as of long type, you postfix the digit with a capital L or a small l. For example, 025L. Since it starts with a 0, it's an octal number, and it ends with a L, means it is of long type. So the decimal equivalent of this number will be 21. Integer variable declarations. To declare variables, you can simply declare individual variables as of integer var1. If you want to define multiple variables on the same line, then you can say integer variable1, comma, variable2, and so on up to variable n. To declare a long integer, you need to use the keyword long. So long integer var1, or optionally you can also just say long var1. To declare a short integer, you will say short int var1 or just short var1. If an integer is to be defined as an unsigned, then the keyword unsigned is to be prefixed. So unsigned integer var1 indicates that variable 1 is an unsigned integer. Optionally, you can also say unsigned var1. To ensure portability of programs, we should always use long integers. Long integer data type. Long integer stored in two words, that is 32 bits. On machines with word length less than 32 bits, on 16-bit machines. Range of long integer is -2 gig to +2. A long integer, long int, would occupy 4 bytes of memory, which is double the size of integer on a 16-bit environment. The value of long integer can vary from -2 giga to +2 giga, that is 2 billion. Integer numbers are denoted by suffixing L or capital L. For example, 1, 2, 3 small l or 1, 2, 3 capital L. Float data type. Floating point numbers or real numbers could be written in two forms: fractional form and exponential form. The value can be positive or negative. Default sign is positive. No commas or blanks are allowed. In the exponential form representation, the real constant is represented in two parts. The part appearing before E is called the mantissa, whereas the part following E is called exponent. The first type of floating point number is float, which is a single precision real number occupying 4 bytes. Let's have a look at these examples. 1, 2, 3, 4 dot is same as saying 1, 2, 3, 4 dot 0, 0. Or 2.6912E4 is similar to saying 26912. Or a number 0.69953E minus 4 is same as 0.000069953. Similarly, a number 0.259E2 is same as 25.9. As I just mentioned, the internal representation is for 4 bytes, 32 bits. A double float number will occupy 64 bits, that is 8 bytes. To declare a variable of the float data type, you specify float followed by the variable name. Example, float variable, average. Double float, variable name. Double, variable name. Character data type. A character data type stores a single alphabet, a single digit, or a single special symbol enclosed within single inverted commas. In the machine representation, character constant occupies 1 word, whereas a character variable occupies 1 byte. Character can be either signed or unsigned, both occupying 1 byte each, but will have different ranges. A signed character is same as ordinary character and has a range from -128 to +127, whereas an unsigned character has a range from 0 to 255. Some special character constants or escape sequences although they may have two characters in it, but they are treated as a single character, and the slash preceding it is treated as a escape sequence. For example, /n, /v, /r, /quote, /p, /t, and /f. Declaring variables of character type. Character C will define a variable C of type character. Character response, answer will define two variables of character type. Similarly, character var1, car2, and so on up to var_n. Now let us see about character input and output. In C, the functions provided to input or output characters are getChar and putChar. You can define a variable of integer type or of character type. For example, character C, and I can mention C is equal to getChar. So getChar is a function that inputs a character and stores the value in the variable C. Similarly, int C and C is equal to getChar. So in this case, the value accepted by the getChar function will be stored in the variable C. The reason we can do this is because getChar returns the ASCII value from the range 0 to 255. Now let's have a look at all the data types, their range in environment, and the usage. Depending upon the compiler that you are using, these range in environment will vary. It could be 16-bit or it could be 32-bit. Character, as mentioned, in a 16-bit environment will take -128 to 127. In a 32-bit environment, it remains the same, and its usage is to accept a single byte capable of holding one single character. Short integer. It is in a 16-bit representation as -2 to the power 15 to 2 to the power 15 minus 1. In a 32-bit environment, it is -2 to the power 31 to +2 to the power 31 minus 1. An integer short range. Same is for integer. So in short, the short integer and integer are same. Long integer. In a 16-bit environment, it will be -2 to the power 31 to 2 to the power 31 minus 1 to 2 to the power 31 to 2 to the power 31 minus 1 in 32-bit environment. An integer long range. A floating number that provides single precision floating point will occupy 4 bytes, and the range is -3.4 E38 to +3.4 E38. Whereas a double precision floating point will take -1.7 e to the power 308 to +1.7 E308 8 bytes. Unsigned integer will allow only positive integers, and the range is from 0 to 2 to the power 16 minus 1 in a 16-bit environment, whereas in a 32-bit environment it is 0 to 2 to the power 32 minus 1. Unsigned character. In a 16-bit environment as well as in a 32-bit environment, the range is same, that is 0 to 255, that allows only positive byte values. So that was all about the data types and their sizes. In this part, we have discussed about the primitive data types, that is integer, character, float, and double.